a racing machine screams past you. In a blur of color and noise, you feel the ground shake. It is an assault on the senses, a pure hit of adrenaline. But beneath all that raw emotion, there is something else at play. It is a quiet, relentless force. It is the force of science and engineering. Every single millisecond gained, every fraction of a G pulled, is the result of countless hours of calculation, design, and testing. Formula One is the absolute pinnacle of this engineering obsession. It is a world where budgets are vast, and the technological envelope is constantly being shredded. The most visible science is aerodynamics. Front wing, rear wing, sculpted floor, intricate barge boards, every surface has a job. They manipulate the air, forcing the car down onto the track with immense downforce. That is what lets it corner at speeds that defy logic. A 1.6-liter V6 turbo and electric motor generators, orchestrated by sophisticated software, astonishingly powerful and efficient. Carbon fiber monocoques, exotic alloys, ceramic brakes, and hundreds of sensors feeding the lifeblood of data. To the casual observer, NASCAR might seem like a brute force exercise, a throwback to a simpler era of motorsport. But don't let the familiar silhouettes fool you. Beneath the surface, the engineering challenge is every bit as intense as any other top-tier racing series. These are not stock cars. They are purpose-built racing machines, and the fight for victory is waged in millimeters and milliseconds. In fact, it's the incredibly strict rulebook that amplifies the challenge. With every team forced to operate within a tightly defined technical box, innovation is driven into the shadows. Engineers must find microscopic advantages, exploiting every loophole and interpreting every regulation to its absolute limit. This relentless pursuit of marginal gains is where races are truly won and lost. The core of the car is a rugged, heavy steel tube space frame chassis, a stark contrast to carbon fiber monocoques. Paired with a massive, naturally aspirated V8 engine, it's a formula refined over decades. These pushrod power plants, generating over 750 horsepower, are masterpieces of mechanical optimization, tuned to deliver reliable, thunderous power for hundreds of miles. On the superspeedways, aerodynamics dictate the race. The lead car expends enormous energy, punching a hole through the air, creating a low-pressure pocket in its wake. A trailing car can tuck into this draft, experiencing significantly less drag. This allows the driver to use less throttle to maintain speed, saving precious fuel and reducing strain on the engine. Teams spend millions in the wind tunnel and on computational fluid dynamics, searching for the perfect aerodynamic balance. Tiny, almost invisible adjustments to the shape of the nose, the angle of the rear spoiler, or the taping on the grille can dramatically alter downforce and drag, turning a mid-pack car into a genuine contender. Mechanical grip is just as critical. The setup is a black art. Spring rates, shock absorber clicks, and minute changes to camber and toe angles are all meticulously tuned. For oval racing, cars even run asymmetric setups, optimized to do one thing perfectly: turn left at incredible speed. The smallest details have the biggest impact. A single quarter-pound of air pressure in one tire can completely change the car's handling balance, defining the razor-thin line between frustration and a trip to victory lane. This precision extends to the pit lane. In a breathtaking 12-second ballet, the crew swaps 4 tires, fills the car with fuel, and makes chassis adjustments. It's a perfectly rehearsed fusion of human athleticism and engineering, where every second saved can rewrite the outcome of the race. Across all these incredible disciplines, from the dirt stages of rally to the high banks of Daytona, one thing remains constant. The relentless pursuit of speed is a deeply human endeavor. The technology, no matter how advanced, is only as good as the people who create and operate it. It's the synergy between driver intuition and engineering precision that unlocks the final tenths of a second. A driver's subjective feeling, The rear feels nervous on entry, becomes a concrete engineering problem. That feeling is translated into data, which then informs a damper click, an anti-roll bar adjustment, or an aerodynamic tweak. This is the art of turning feel into speed, and the benefits of this relentless cycle extend far beyond the racetrack. The hybrid systems that harvest braking energy in a Formula One car, the incredibly efficient engines from Le Mans, and the lightweight composite materials perfected across all series, this is racing tech that now lives in our everyday road cars, making them safer and more efficient. Motorsport has always offered a window into the future of transportation. Today, that window shows a path towards sustainability. Teams are pioneering advanced biofuels, developing next-generation battery chemistries, and even exploring hydrogen power. This is the spirit of motorsport. It urges you to ask questions, to challenge assumptions, and to never, ever accept the status quo. It's a mindset that inspires the next generation of engineers and thinkers to seek elegant solutions to complex problems. From the humble go-kart to the pinnacle of Formula One, the same fundamental principles of physics and engineering are the keys that unlock speed. The journey of learning starts small, but the ambition is limitless. It's a world where theory meets the harsh reality of the track, where digital simulations are validated by real-world data. You simulate, you build, you test, and you iterate, again and again. Because in the world of motorsport, the race for innovation never truly ends. Don't forget to like, share, and subscribe ET Mustard.